All right, good morning, guys. Welcome to a new lesson. In this lesson 2.4, we're going to be looking at rotations. So this is what your note sheet should look like, both color-coded and the way that you're going to fold it. So you're going to simply fold the rotations note sheet, which is front and back, almost in half, but we want to offset it enough just so we can see that rotations tab. All right, let's get to work. So in 2.4, we're talking about rotations, which is our third type of transformation that we're covering. The first being translations, and then we talked about reflections, and now rotations. So when we're talking about rotations, the type of movement that we're referring to is either a turn or a spin. So if you think about a merry-go-round, when you spin around a merry-go-round on the park, that's a rotation, all right? Or if you're on a Ferris wheel, again, that's a rotation. So there's three things that we need to know in order to successfully do a rotation. The first thing we need to know is what we're rotating around. And that is always going to be a point on a graph, and we call that point that we're rotating around or about, we call that the center of rotation. Now, for our purposes, the center of rotation in this lesson and what we do together is always going to be the origin, or in other words, 0, 0. More advanced problems with rotations will use different centers of rotation, but for what we do in this lesson, that's what it's always going to be, okay? The second thing that we need to know to do a rotation is how far we're going to rotate, which is the number of degrees a figure rotates, and we call that the angle of rotation. You might be confused that we would use an angle to measure the distance of a rotation. But if you think about, and actually I'll just show you real quick, if we were to take this smiley face right here and rotate it, notice that they're measuring how far we spin it in degrees. All right. And so they're measuring a rotation. This program measures a rotation in degrees. That's an angle of rotation, or how far we spin something. And so the types of angle measurements we're going to see are first 90 degrees, 180 degrees, and 270 degrees. These are all multiples of 90. These are the three distances that we will get comfortable with in this lesson. The third thing that we didn't put in the notes that we should have is the direction of rotation. So not only do we need to know what we're spinning around, we also need to know how far we're going to spin. We also need to know in which direction are we spinning. So the direction of rotation refers to one of two options. The first direction spins the same way that a clock does, and we call this direction clockwise. So when you think how the hands on a clock move, that's the direction clockwise. And then the second direction would be opposite of that, which is what we call counterclockwise. So if we turn to the right, that's clockwise. If we turn to the left, that's counterclockwise. Okay, so there's basically three distances that we can go. And actually, in reality, there's only really three rotations that we could do, because there are some rotations that, regardless or that depending on distance and or depending on degree and direction, create the same image as another thing. And I'm going to explain this to you a little bit further down the road. But the first thing is, notice that these examples down here of angles of rotation, they tell you a distance or degree, and they tell you a direction. 90 degrees clockwise is actually the same exact rotation as 270 degrees counterclockwise. I'm going to explain this to you a little bit, or I'll explain it to you further here in a little bit, okay? 180 degrees clockwise is the same as 180 degrees counterclockwise. Even though they're different directions, they create the same image or the same new shape. And then finally, we have 270 degrees clockwise is the same as 90 degrees counterclockwise. So like I said, we'll talk more about that on the second page. So the most important thing that you can get from these notes are actually not even in your notes yet. Okay, this table right here is super important. Okay, so what I want you to do is pause the video right now. You're going to pause the video and make this table in your notes. Okay, ignore this part right here that I'm scribbling out. You don't need to color code it, but you do need to get every piece of information that's on this table written down in your notes. So you need the degrees and the directions for each one of these rows, and you got to get those written down correctly, okay? Without this table, this lesson is going to be pretty challenging, but using this table, it's actually relatively easy. While you also have your video paused, you can go ahead and write down your coordinates for each example and then color code in the same way that we have here. Okay, so do that now, pause the video, get this information down before you start it back up. Okay, so our rules for rotations. These work a lot like the reflection rules worked in the last lesson. Okay, basically we're going to use these rules to change the ordered pair of a point in order to rotate it. So if I want to rotate a shape, let me zoom in here a little bit. If I want to rotate something, whether it's a point or a figure, if I'm going to rotate 90 degrees clockwise, I'm going to change XY to Y negative X. Okay, now what this means is that I'm taking the ordered pair that I'm given, I'm going to flip the order of the numbers and change the sign of the second number. Okay, to do a 90 degrees counterclockwise rotation, I'm going to change XY to negative YX. So this time I'm still flipping the order of the numbers, but this time I'm changing the sign of the first number. Okay, so I told you a little bit ago that a 90 degrees clockwise rotation was the same thing as a 270 degrees counterclockwise rotation. So what I'm saying to you is that if we want to do either 90 degrees clockwise or 270 counterclockwise, we're going to use the exact same rule. So this rule is exactly the same as our first example was. We changed XY to Y negative X. The same thing is true for 90 degrees counterclockwise and 270 clockwise. The rules are the same. So we change XY to negative YX. So in other words, these two rotations create the same image or the same new shape, and these two create the same new shape. The last rotation we have is a rotation of 180 degrees. And this one is unique because it doesn't matter which direction we go, we're going to create the exact same rotation image. XY changes to negative X, negative Y. So in this case, we don't flip the order of the numbers. We just change the sign of the numbers. Okay, so let's actually put this into practice. So here's our first example. We're told that the vertices of a triangle are A31, B34, and C11. They want us to rotate the figure 90 degrees clockwise. So they've given me the points of the original triangle, so let's go ahead and plot those. So A is at 3, 1. So here's A. B is at 3, 4. So here's B. And C is at 1, 1. Okay, so here is our original triangle. Okay, so we're going to rotate this thing 90 degrees clockwise. Now, one thing I forgot to explain to you is that when we rotate a shape 90 degrees, we're going to be rotating it to one whole new quadrant, because each quadrant is created by a 90-degree angle. So if I'm rotating 90 degrees, I'm moving one quadrant either to the right or to the left, depending on the direction. And since I'm going clockwise, I'm going to be moving to the right in the direction a clock moves. So I know, based on just the directions they've given me, that I'm going to wind up in this quadrant. I'm going to move one quadrant because it's 90 degrees. If it was a 180-degree movement, I'd be moving two quadrants. So I'd be moving all the way over here. If it was a 270-degree movement, I'd be moving three quadrants, so I'd wind up here. Okay, so that should help you in terms of figuring out whether you are moving in the right direction. Now, this is actually very simple using our rules. So let's find our 90 degrees clockwise rule. So for the 90 degrees clockwise, we're going to change XY to Y negative X. So what this is telling me to do is I'm going to flip the order of the numbers. So 3, 1 becomes 1, 3. And then I'm going to change the sign of the second number. Now, when I plot this, I'm still plotting it in the same way I always do. The first number is X, the second number is Y. Even though my rule says YX, I still plot it normally. I'm just using that rule to find the new point, okay? So the new A, or A prime, will be at 1, negative 3. And that makes sense because I know I'm moving this triangle one quadrant to the right. So, or one quadrant clockwise. So I know that the triangle is going to be down here. Let's go ahead and do the other points. So 3, 4, I flip the order of the numbers. So I now have 4, 3, and I change the sign of the second number. And then 1, 1, I flip the order of the numbers, which doesn't matter in this case, and I change the sign of the second number. So 4, negative 3 is here, and then 1, negative 1. So this is A prime, this is B prime, and this is C prime. And so notice that the shape is actually pointing in a different direction now. But if you can visualize the original triangle rotating around the point of origin, which is what we're always rotating around right there, each point has to stay the same distance away from the origin. So the whole thing is spinning, almost like it has metal rods attached to each point, okay, from the origin. So that's how we rotate a shape. We figure out what our direction and degree is, and we look at our rule, and we just simply change our coordinates. It's real simple. All right, let's do another one together. So they tell me that we have our triangle ABC. Let's go ahead and plot those points, which we have written down. So A is at negative 3, positive 1. B is at negative 3, positive 4. And C is at negative 1, positive 1. So here's our new triangle. So this time we're going to be rotating 270 degrees clockwise. So I know that I'm going to rotate 3 whole quadrants. So if my shape ends up here, that's a 90-degree turn. If it ends up in this quadrant, that's a 180-degree turn. And going 270 degrees will make it end up in the third quadrant right below. Okay, so I know that my shape should wind up in the third quadrant down here. All right, so let's go ahead and find our rule. 270 degrees clockwise The rule for that is xy becomes negative yx. So this rule is a little bit different than the last one. So xy becomes negative yx. So this time we're still flipping the order first. So we always flip the order first. So 1, negative 3. And this time we're changing the sign of the first number. We flip the order for negative 3, and we change the sign of the first number. We flip the order 1, negative 1, and we change the sign of the first number. So we can go ahead and plot these. Negative 1, negative 3 is here, so there's A prime. Negative 4, negative 3 is here, so there's B prime. And negative 1 is here, so there is C prime. So we definitely made it to the correct quadrant. Moving clockwise, that is a 270 degrees rotation around the origin. Okay. Let's try one more. It's really hard to grab this with my pen. Okay. So this time we're going to be rotating our shape 180 degrees counterclockwise. Okay, so first let's plot our original image, which is called the pre-image. So A is at 3, positive 1. So there's A. B is at 3, positive 4. So there's B. And C is at 1, 1. So there's C. Okay, so we're going to be rotating this time 180 degrees counterclockwise, excuse me, which means we're going to be moving the opposite direction. So 180 degrees means we're moving 2 quadrants away. One quadrant would be a 90 degrees rotation. 2 quadrants would be 180 degrees. So I know that my shape should wind up in this quadrant down here, okay? So my rule for 180 degrees rotation, whether it's clockwise or counterclockwise, is xy becomes negative x, negative y. All right, so we're going to change xy to negative x, negative y. Now, this doesn't mean that we're making all the numbers negative. It just means that we're changing the sign of everything, which every example I've shown you so far has been changing positive to negative, but it's not always that way. Okay, and the last example I'll show you what I'm talking about. So I don't need to flip the order this time, like I did in the previous examples. This time I am just simply changing the sign of the original numbers. So 3, 1 becomes negative 3, negative 1. 3, 4 becomes negative 3, negative 4. And 1, 1 becomes negative 1, negative 1. So all I did was change the sign of every number, but leave them in the correct order. Now I can plot my shape. So, and I realized that I've been using orange this whole time when I should be using pink. Sorry, Spear. All right. So negative 3, negative 1. There's my new A. So that's A prime. Negative 3, negative 4, there's B prime, and negative 1, negative 1, there's C prime, and my shape is in the correct quadrant, which is 2 quadrants away from the original or pre-image. All right, so that's what a 180 degree rotation looks like. So I want you to go ahead and pause the video and try this last problem on your own. Make sure you use the correct rule from the table and give it a shot. All right, so I'm going to start by plotting my pre-image. So 3, negative 1 for A. So here's A. 3, negative 4 for B. So here's B. And 1, negative 1 for C. So there's C. So there's my pre-image or original shape. So this time they want me to go 90 degrees counterclockwise. which if I'm going counterclockwise, that means I'm moving to the left. So I know my shape should wind up somewhere in this quadrant, okay? So 90 degrees counterclockwise. Oh my goodness, this is really hard to grab. Okay. So for a 90 degrees counterclockwise rotation, we're using this rule right here. XY becomes negative YX. Okay, so this time I'm starting by flipping the order of the numbers. So 3, -1 becomes -1, 3. And then I'm changing the sign of the first number. So -1 becomes +1. This is what I was just talking about in the previous example. We're not always making numbers negative, okay? We are changing the sign of numbers. So if it is negative, it becomes positive. If it's positive, it becomes negative, okay? So -4, 3 for the second one, and then I change the sign of the first number. And then 1, -1 becomes -1, 1, and I change the sign of the first number. So I can plot my new shape. 1, +3, so there's A prime. 4, +3, so there's B prime. And 1, 1, there's C prime. And I wound up in the correct quadrant, so I know I did this correctly. So that's basically rotations in a nutshell. If you use the table of rules and you find the correct rule, then this isn't that challenging. You just have to really pay attention to the details here, guys. You can't rush through this stuff. So it might seem really tough at first, but I promise you with practice, it will get really easy. All right, so our last example is a visualization question. This question is really asking, like, can you visualize a rotation in your mind? Okay, now to help you see this, I'm going to actually use the rotation tool here. But basically, what we're doing is we're trying to figure out which of these multiple choice options represents a 270 degrees clockwise rotation. So I know that for a 270 degrees clockwise rotation, I'm rotating almost a full circle. I know that because that would represent 3 quadrants, right? So I'm rotating almost in a full circle. So when I visualize this, one thing that helps is to actually see it. So I'm going to use my little rotation tool. So if I rotate my original shape 90 degrees, that's what it would look like, where this node that used to be on the top is now on the right side, and the node that used to be on the right is now on the bottom. So option A is not the correct option. This is a 90 degrees clockwise rotation. Okay, so that does not work. All right, so let's keep going. So we've already gone 90 degrees. And actually I'll have to fill those out later. So 90 degrees, there it is. That's what it looks like. 180 degrees would create a shape that looks like this, where the nodes are on the bottom and the left. So B would be 180 degrees rotation, not 270. And 270 would move it 3 whole quadrants, and that's the image we would create. So option C is the image we want. Option D is actually a reflection of the original figure. It's not even a rotation at all. So option A was a 90 degrees rotation. Option B was 180 degrees rotation. Option C is our 270. And then option D is not a rotation at all. This is a reflection. So the more you do this, the more you're going to be able to visualize that kind of problem. All right, so that's all I have for you guys. Thanks for watching, and please let us know when you need help.